Welcome to another episode of the electro demo. I hope all is well. So today we are going to talk about how to reduce your solar cost. So today's solar cost typically would run from $10,000 to $20,000, especially for a total standalone system, because of the certain loads that we're going to talk about. So, in this episode, we're going to show how to reduce 75% of those loads and also simplify some of these loads. Okay, so we're going to start with our pie chart, and we can see by looking at this pie chart, we have some of the big loads, which is the air condition, the cooking, the refrigerator, and the phantom loads. So we are going to start with the air conditioning. And the air conditioning here is the way I'm going to approach this is you need to keep the temperature as close to room temperature as possible, one way or the other. So what we're going to do in this slide, we're going to show how we could eliminate the heavy loads of air conditioning, make your housing very efficient where the cooling is acceptable. Okay, so if you see in this slide here, we have two views. You see the one at the bottom with the X. Here you have the typical design where the air goes inside the rooms, but they can't come out, so the air gets trapped. So there's no cross ventilation. Cross ventilation is very crucial. It's been found that with cross ventilation, you can actually reduce your temperature by 10 to 20 degrees. So, in other words, if it's 90 degrees Fahrenheit, you could reduce it close to 70 or room temperature 68 degrees just by cross ventilation. And of course, you're going to definitely make sure your house is properly insulated too. So yeah, so if you look at the top, with the blue, you can see the air is going through the top, and then it goes through the house and come out the other side. And you can also see in this other picture right here, see cross ventilation makes a huge difference. Sometimes you have to change your house design a little bit. Sometimes you could make it a little bit narrow. Sometimes you could make it like even of the shape of a donut, where the inside is hollow, so the air would go through and then come out. Okay, so we're going to go back to our pie chart, and then the air conditioned one is solved. So we're going to take that one out. Okay, we don't need the heavy load of the air conditioner. And by the way, the reason why air conditioners are high temperatures because of the compressors. The compressors have a tendency to demand a lot of current, cause a lot of amp to be drawn out of your system. All right. So the next item we're going to look at is the one below, which is the green. And here we'll take a look at a typical kitchen, as you see here. And this is your kitchen, but then we're going to look at the kitchen stove as we zoom into this electrical stove right here. This electric stove, typically they're about 1,000 watts. It's not a heavy load, and then we're going to eliminate that by using a gas cooker. The nice thing about gas cookers, they're typically known to be top end. People who have top end houses typically like the gas stove better than the electric stove to begin with. So in this case, why not use it? That way, we would free the burden from our very expensive solar energy. So we could use any kind of natural gas. You could use also propane. You could use what they call marsh gas or methane. Yeah, so any type of gas that you have in your system, you could use that. Okay, so we're going to go back to our graph again, and then the green part of the pie, boom, that one is out of there. So the next one we're going to talk about is the blue part of the pie, the refrigeration. So here we're going to have a different approach. And here, so we're not really we're reducing the costs. So if you look at this circuit, circuit right here, there's something missing. And if you take a look at it for a couple minutes, you probably realize where all the batteries. Well, in this case, we don't have any battery systems. What we've done is during the daytime, the solar panel charges the contents in the um, refrigerator or the freezer. So it's key now that you have to have something in the freezer. And if you don't, if it's empty, you got to put some water in there. Because what you're gonna do is you're gonna cool these down to below temperature or to freezing, and then you're gonna use that energy, that thermal energy, for the time during the night, and then that energy would be used as storage. So rather than have batteries, you're using thermal energy. So you've simplified it. There's some pros and cons. Of course, the pro is very simple. There's no battery, so this thing will last for years. It will last over 20 years. Of course, the con is you got to be careful of the temperature because maybe you don't want to freeze your stuff. Sometimes you just want to make it cold, not freeze. But a lot of times in practical living, you just want to freeze everything, and then you could probably put another container next to it with insulation so it's not going to get as cold. Okay, so this is a battery-less freezer. We'll talk about this in some other channel. So this is great. This takes the system, the load off the main system, and it's kind of like a standalone system by itself. So we'll go back now to our pie chart, and we'll take a look at the blue, and the blue is out of here, out of there. So you can see right now we're close to 50 to 60% of our load, and now we'll talk about the other load, which is the red, which is the phantom. So by phantom is it's kind of like a silent or hidden or ghost energy, and this typically would be stuff like your laptop charger, your cell phone charger, or your any type of appliance that's hooked up. By appliance, I mean, say you have a, um, a coffee maker. You have anything that you stick on the wall, even a laptop um, supply cord that's not even hooked up to the laptop. Just leaving it on the wall, the transformer itself, um, the primary circuit is still running, and it's kind of like drip, drip, drip because the power source here is very low, but because they're on 24-hour, they add up because the kilowatt hours is always a multiplication of either the amount of current or time. In the past, and we've been talking about stuff that have high currents, but the time is very low. Well, this one is the opposite. The the time is very high and the current is low. So the final product is the same. And so this what we call phantom loads would actually add up to about 25 plus of your total loads. So the key point here is to unplug these phantom loads, and that will reduce your power source. All right, so we go back to our pie chart. So the red one here, we put a big X here, and that's gone. So now you can see what's left now are the low loads, which is the fan, the lights, and your computer. Again, hopefully you never unplug your computer in and some other. And that's typically just 25%. And so the 25% you can see on circuits like this, where you just have a very simple solar system. You know, you have your one module, you call it a solar generator because it's like a little box, and that box has its own inverter, it has its own battery. Usually, it's the new type of battery, which are the lithium batteries, not the lead acid battery, and they range anywhere from 200 to about $2,000 depending what your sizing is. But this one unit that's very small, within the size of 2 feet cube, you could basically have everything that you need. Your 120 or your 220 if you overseas, your USB or USB-C, or everything's all on one unit, and you could power your fan and your lights and your your TV screen and your computer, and that's the rest of the 25%. All right, so here we go. So we've pretty much reduced our load from um, basically the $10,000 to $20,000, which these new solar systems for your standalone house typically would cost. We've reduced that to 75%. So your actual cost now would be somewhere between 3,000, about 9,000. So 3 to 9,000 is your new cost compared to your original um, uh, 10 to 20,000. Okay. All right. So if you like this channel, please go ahead and subscribe. Click your notification and share. Again, this is Electro Demo. Thanks.